All right, kidlets, we are solving log equations. Remember on Friday that we undid exponents by taking logs. And on Thursday that we converted log equations to exponential equations by making the logs exponents. That process is called exponentiating, and you'll see that in the directions down on the bottom of this worksheet. This is a notes page, so just watch the problems as we go through. If you want to write them on your own paper, you can. This is not the worksheet that you're going to get in class, though. Okay. First, we're going to talk about equations with logs on both sides. The way that you solve an equation with a log on both sides is first that you make sure that there aren't any coefficients in front of the logs. So, we don't have a 2 or a 3 sitting in front of our log. None of our equations have that happening. So we just want to make sure that's not there. After that, we want to establish what the base of the log is. So I'm looking at this log equation right here. And if you see, it is just log x is equal to log 6. And remember that when we have a log without a base on it like that we have a base of 10. Remember that we have a base of 10. It's called the common log. All right. And the way that we solve this equation is that we make both of those logs into an exponent with a base of 10. So we write this as 10 raised to the log of x is equal to 10 raised to the log of 6. And what happens is that this simplifies to x and this simplifies to 6. It's because the base here and the base here are the same. And so we get x is equal to 6. The logs go away and we're left with numbers and variables. We have to, when we're doing log equations, we have to check and make sure we don't have any extraneous solutions. An extraneous solution is anything that would make the log negative. So if we plug this back in, is it going to give us a negative number inside a log? So if the x equals 6, if I plug it back in there, it's log of 6. That's okay. We're good. It's not extraneous. Let's look at this one. These logs have a base of 3. And so what we're going to do is we are going to make them exponents with a base of 3. And so we write the big 3 here and the big 3 there. So we got 3 raised to the log base 3 of 8x is equal to 3 raised to the log base 3 of 2x minus 12. And what happens is that the 3 raised to the log base 3 simplifies to 8x, and the 3 raised to the log base 3 of 2x minus 12 simplifies to 2x minus 12. And then what we do is just solve for x. And x equals negative 2. Now, we want to make sure that if we plug that number in to our original equation up here, that it's not going to give us log of a negative number. So if I take negative 2 and plug it in for x, 8 times negative 2 is negative 16. I cannot take log base 3 of negative 16. It doesn't work. And so what we do is we say, that solution doesn't work. It's extraneous. Okay, over here we have natural log. Remember that with natural log we use e, right? Remember on Friday with e we use natural log. Well, with natural log we use e, and so what we do is we make those natural logs an exponent on a base of e. So we have e raised to the natural log of 3x plus 5 is equal to e raised to the natural log of x minus 9. And that simplifies to 3x plus 5 is equal to x minus 9. So 2x is equal to negative 14 and x is equal to negative 7. And so again, we want to check and make sure that this is not going to make either of those logs negative. And so I take this -7 and I plug it in. Either one will work. Well, you've got to check both. But I plug it in here. So 3 times -7 is -21. Plus 5 is -16. We cannot take the natural log of -16. It won't work. If you try it on a calculator, it will tell you error. And that means that this also is an extraneous solution. And so we just cross it out and write extraneous. That is how we solve a log equation when you've got a log on both sides. What you do is they've got to have the same base, which is all of your problems will, okay? And then what we do is we make the log an exponent on the base. So whatever that base is, in this case it was an e, so we make the log an exponent, okay? Doing that enables us to pull whatever was in the log out, all right? And then we just solve the equation. Now, if you only have a log on one side, the way you do this is you get the log completely alone, and then you do the same thing with the exponents. You exponentiate, which means that you make both sides of the equation an exponent on the base, whatever the base of the log is. Here again, we don't have a base number, and that means that the base is 10. Now, my log is completely alone. I don't have a +3 or a -5 or a 2 hanging out in front. And so I can go ahead and exponentiate, and I'm going to use a base of 10 again because there isn't a base number here. And so I'm going to write a big 10 and a big 10. And what happens is, so this is 10 to the log of x is equal to 10 to the 5th. What happens is that 10 raised to the log of x is just x, and that's equal to 10 to the 5th. Now, if you can multiply out this number, please, if it's 2 squared, tell me 4, okay? But 10 to the 5th, I mean, you could very easily just write the zeros, but you don't have to. If you want to leave it like that, that's fine with me. All right, looking at number 5, again, step 1 is get the log alone. And so I'm looking at this, and I know that there's a -6 here, but see how it's in the parentheses. So it's part of that log. So my log is completely alone. It's log base 3, okay? And so what I'm going to do is I'm going to exponentiate it. So I'm going to make it an exponent. I'm going to do that with both sides of my equal sign. And so I've got log base 3 raised to the log base 3 of x minus 6 is equal to 3 to the 5th. And what happens is we get x minus 6 is equal to 3 to the 5th. 3 to the 5th is 243. You guys have calculators in front of you. Most of the time you can do that. Okay, and that means x is equal to 249. We still want to check and make sure that this isn't an extraneous solution. I forgot to do that with number 4. Trust me, it's not extraneous. So what we do is we just plug that value into the log and make sure it's not going to end up with a negative number. 249 minus 6 is 243. We're good. We're safe. So this is not extraneous, and that is my solution. All right. So for this one, I'm looking at it, and again, there's an 8 there, but that's part of the log. And so I don't have to do anything to get that log alone. What I'm going to do is I'm going to look at the base, which is 4, and I'm going to raise it and make the log an exponent on a base of 4. And then what we're going to do is we are going to, so again, that's 4 to the log base 4 of 8x is equal to 4 to the 5th. And so this 4 raised to the log base 4 of 8x, the 8x just falls out, and 4 to the 5th power is 1024. And so x is equal to 128. And again, you want to make sure that that is not going to give us a negative number inside our log, but 8 times 128 is positive, so we're good. We're good. That's our answer. All right, one of the things you want to remember to do is if we have two logs like this, see there are two of them, we have to put those logs together. And so we have to do that first. So you end up with log base 6 of x times x plus 5 is equal to 2. And so we put them together. Remember, that's the property of logs, is where you add the logs. What happens is you multiply the things inside. Property of logs. And so now what we have is an equation with a single log. And so what we're going to do is we're going to exponentiate, which means I'm going to make that log an exponent on that base. So it's a 6. So 6 raised to the log base 6 of x times x plus 5. I'm going to exponentiate the other side as well. And so we end up with x times x plus 5 is equal to 36. And I know you guys are super excited because what you have here is a quadratic equation. And who wouldn't be super excited to solve that? So remember, we set it equal to 0, and then we try to factor. This factors to x plus 9 and x minus 4. I'm going to zoom out just a little bit. And that means x is equal to -9 and x is equal to +4. And we have to check and make sure that neither of these numbers will make our logs negative. So if I try -9, -9 plus 5 is -4. That is not going to work. That is extraneous. 4 does. 4 is fine. So 4 plus 5 is 9, and 4 on its own is positive. So we're good. So our answer here is 4. I would expect to see your -9 and see that you had marked it out and said extraneous, though. All right. We also have this natural log right here, and we solved this one the same way we solved number 5, which is the one that was above it. This is, again, we use an e because it's a natural log. And so when we do that, we end up with x plus 12 is equal to e cubed. Now with this, like with that x to the 5th I showed you earlier, guys, e to the 3rd is a decimal. It's a long decimal. It's an irrational number. So what we want to do is we just want to leave it e cubed. And so just solve for x. We subtract 12 from both sides, and I get x is equal to e cubed minus 12. And you're done. Sort of like the log equations from Friday. All right, there's one more equation I want to show you because there isn't one like it on this note sheet, and that is if we have like 2 log of x minus 4 plus 5 is equal to 11, let's say. And so what you can see is that that 2 is out in front. I've got a plus 5 over here. The 4 is part of the log, so we leave it alone. But I need to deal with the 5 and the 2 before I can solve this log equation. So we get the log alone. So I'm going to subtract 5. We got 2 log of x minus 4 is equal to 6. Divide both sides by 2, and I get log of x minus 4 is equal to 3. And now I can exponentiate. I can raise this to a power and solve. Now, notice it's just log, which means it has a base of 10. And so I'm going to say 10 raised to the log of x minus 4 is equal to 10 raised to the 3rd power. And so what I get is x minus 4 is equal to 10 to the 3rd. And 10 to the 3rd is 1,000. So x minus 4 is equal to 1,000. X is equal to 1,004. I want to make sure, plugging it back into my original equation, that it's not going to give me a negative number. 1,004 minus 4 is 1,000. We're good. It's a positive number, and we're fine. And so that's my solution. But see here, I had to get the log alone. And so that's what you do. If there's only a log on one side, you get the log alone, and then you raise it to a power using the base from the log. remember that if there's more than one log, it's not something you can't handle. You just have to put the logs together. So this problem right here, there was more than one log, and so I put them together, and I used those properties of logs that said that if we add the logs, we multiply the things inside them. All right, guys, I hope this was helpful. Do your worksheet. You get 10 bonus points if you turn it in today, and I will give you 5 bonus points for turning it in on Tuesday, even though technically it is due on Tuesday. Hope you have a good day.